Okay, so we're going to be going over chapter 18.7, which is solving radical equations. So the concepts we're going to go over are solutions to radical equations, solving radical equations involving one radical, solving involving more than one, and then some applications. So for the first concept, solving a radical equation is one or more radicals containing a variable. So for example, one or more radicals containing a variable. For example, we could have that a is equal to the nth root of a raised to the nth power. So it's something we talked about previously, that if we had the matching index with the matching exponent, they cancel out and we're left with whatever is inside of the radical. Okay. Another vocab here is extraneous solutions. So an extraneous solution is a solution that doesn't make sense once you plug it back in. So it's a solution that doesn't make sense once you plug it back in. So on previous notes, remember we had to plug in our answers to verify if they were true statements. So we're going to do the same thing here. So an example of an extraneous solution is solving the equation the square root of x is equal to negative 7. Okay. In order to solve this and solve for x, what do we have to do to both sides to cancel out that square root? How do we cancel out a square root? You guys remember? Square it. So remember, the index for a square root is 2. So we would square both sides, and we would get x is equal to negative 7 squared, which is 49. Okay? If we were to plug that 49 back into our original problem, so this is the check, the square root of 49 equal to negative 7. What's the square root of 49? 7. Is that equal to negative 7? No, so this is a false statement, or in other words, we call this a extraneous solution. Or another word for that is no solution. So it's extraneous because it seems like it should work because we did get an answer, but after plugging it back in, we get a false statement. Okay, so it's our two vocabs. And then in this box, it gives you some steps on how to solve a radical equation. I'm just going to highlight the important parts. So step 1, it says isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. So step 1 is to isolate the radical, so to get one of the radicals by itself. Step 2 is raise each side of the equation to the power that equals the index. So if the radical was a square root, that means we would square both sides. What if it was the 5th root? What would we do to both sides? Raise it to the power of 5. So raise each side of the equation to whatever the index is. Step 3 says solve the resulting equation. If the equation still has a radical, repeat steps 1 and 2 until we no longer have radicals. Okay, so just solve the equation. And then lastly, step 4 is to check the potential solutions in the original equation. So remember, we do this because we want to make sure that our solutions that we get are only true statements. So check potential solutions. Okay. And then right here in this little note, it says that extraneous solutions can possibly occur when each side is raised to an even power. So 2, 4, 6, 8, etc. Those are the times when it could potentially occur. So these are our steps. Any questions before we look at some examples? Okay. Okay, so in these examples, we're only looking at ones that have one radical. Okay, so in this case, we have the square root of p plus 5 is equal to 9. We want to get that radical by itself. So what's our first step? Subtract 5. And we get the square root of p is equal to 4. Now that we have the radical by itself, we're going to raise both sides to the index. And what's the index of the square root? 2. So I'm going to square both sides. Okay. When I square a square root, what happens? Cancels. So you're left with p is equal to 4 squared, which is 16. Okay. Before we can say this is our answer, we have to plug it back in and see if we get a true statement. So if I plug in 16 for p, I get the square root of 16 plus 5 equals 9. We know that the square root of 16 is 4, so I have 4 plus 5 equals 9. 9 equals 9. Is that true or false? True, so that tells us what? P is equal to 16. That is our answer. So on these type of problems, I need to see both. I need to see your original, and I need to see your check. Okay. So the original, and then checking your work. Okay, same with number 2. We need to get the radical by itself. So in this case, the radical includes that w minus 1. So if we need to get it by itself, what's our first step? Plus 2. So we have the cube root of w minus 1 is equal to 4. 2 plus 2 gave us 4. Now we need to raise both sides to the index. So what's the index in this case? Power of 3. So we are going to cube both sides. When we do that, the cube root, which is then being cubed, cancel each other out because they're the same. The exponent matches the index. So I'm left with w minus 1 is equal to 4 cubed, and 4 cubed is 64. Now I need to get our variable by itself, so my last step is to do what? Add 1. So if I add 1, I get w is equal to 65. But before I box my answer, I need to check. So I'm going to be plugging in 65 in for w in my original equation. So I have the cube root of 65 minus 1 minus 2 equals 2. So I have the cube root of 65 minus 1. So that's the cube root of 64 minus 2 equals 2. Cube root of 64, you could do that on your calculator. And and you will get 4. So I have 4 minus 2 equals 2. 4 minus 2 is 2, so 2 equals 2. Is that true or false? True. So that means that W equals 65 is my answer. Okay. If I would have got a false statement, then I would say that there are no solutions. No solution. Okay, so looking at number 3, what do you notice that's different between 1 and 2? Do we see a radical?
Not really. We just have to put it in 1.
Correct. So we don't see a radical right away. However, we know that x plus 3 is being raised to the 1/4 power. And if we remember, what does this 4 stand for? If we were to turn it back into a radical. The 4th root. So this is the index. And what is this 1? The exponent. So do we need to write an exponent since it's 1? No. So that means this can be rewritten as 7 equals the 4th root of x plus 3 plus 9. So if we don't see our radical in there, we have to see if we have to change it into a radical first. Okay, so if we want the radical by itself, what's going to be our first step? Good, subtract 9. So I get negative 2 is equal to the 4th root of x plus 3. And now I need to raise both sides to the index. And what is that number? 4. So I'm raising both sides to the power of 4. Okay. That means the radical cancels out because they have matching index and exponent. So I have negative 2 to the 4th power, which is 16, is equal to x plus 3. Last step is to get my variable by itself. So what am I going to do? Subtract 3. So I get x is equal to 13. Before I circle that answer, I need to do what? I need to check my 13. So I'm going to plug 13 into this part of the equation, right? After we already turned it into a radical. Just easiest that way. So I have 7 is equal to the 4th root of 13 plus 3 plus 9. So that means I have 7 is equal to the 4th root of 16 plus 9. If you type in the 4th root of 16 into your calculator, you get 2. So 7 is equal to 2 plus 9. 2 plus 9 is 11, so 7 is equal to 11. True or false? False. So what does that tell us about our problem? What's the answer?
Extraneous solution or extraneous.
Good, extraneous solution, or we can just say no solution. So it's not that 13. Our answer is no solution.
Could you by chance show us the first time how to do the square root on the calculator?
I could show you after class if you want to wait, and I'll show you on the thing. Just because not everyone has the exact same calculator. Okay. You would not have found that the answer was no solution if you did not check your work. Okay, so this would be a big one on the next exam. If you leave it at x equals 13, I know right away that you didn't check to see if it's a true or false statement. Okay, number 4. So before we can start raising each side to the index, we have to get the radical by itself. Okay. What would be our first step to get the radical by itself? We want this part by itself on that side. If we subtract 3, then it's going to get on the same side as the radical. And we want that radical be by itself. So we're only looking at these components here.
Okay.
Subtract y. So I have 2 square roots of 4y minus 3 is equal to 3 minus y. What else is in the way of our radical that we need to get rid of? That 2, so I'm going to divide both sides by 2, and I get the square root of 4y minus 3 is equal to 3 minus y divided by 2. Okay. Now I can get rid of that radical by raising both sides to what power? 2. So I'm squaring both sides. So I have 4y minus 3 because the square root and the square cancel is equal to 3 minus y squared over 2 squared. I went ahead and just gave that square to both of them. Now that we got rid of the radical, we're still going to have to deal with a couple things here because notice that we have a variable on both sides. Okay? So the first thing we're going to do is this part here. This part here is telling us to do what with that parenthesis? Write it how many times? 2 times. And once we write it 2 times, then we will FOIL. So I'm going to write it off to the side. So this is 3 minus y, 3 minus y, and we're going to FOIL this. Okay. So foiling this out, we have 3 times 3, which is 9. 3 times negative y, which is negative 3y. Negative y times 3, which is negative 3y. And negative y times negative y, which is positive y squared. So that's after we FOIL these 2 binomials. Now we're checking if there's any like terms here. What are the like terms that we're going to combine? Good, so this is 9 minus 6y plus y squared. Okay. Each of these terms are going to be divided by what? Because what's on the bottom of our fraction? 4. So each of these are now being divided by 4. And that is because of this right here. Okay. So if I was to rewrite this, I now have 4y minus 3 is equal to 9 over 4 minus 6 over 4y plus y squared over 4. Okay. How could I get rid of those 4's? What could I do to both sides of this equation to get rid of my fractions of those 4's in the denominator?
Multiply by 4.
Good. Multiply both sides by 4. So this entire problem is being multiplied by 4. So I have 4 times 4y, which is 16y. 4 minus 3, or sorry, 4 times negative 3, negative 12. And then the only thing that's happening on the other side is that all those 4's are now gone. So 9 minus 6y plus y squared. Okay. Now that we have no fractions, but we see a y squared in our problem. If we see a y squared, that means ultimately we're going to have our equation equal to what? 0, because this is a quadratic equation. So we need to have everything that is on the right side and move it to the left. Meaning we're going to subtract the 9, add the 6y, subtract the y squared. We're moving everything over here, so it's going to be equal to 0. So we are now looking up here. Okay, so when I do that, my only like terms here are that 16y and that positive 6y and that negative 12 and negative 9. So that means I have negative y squared. Now I'm going to add the like terms that have my y's. So what's 16y plus 6y? 22y. And then negative 12 plus negative 9 is what? Negative 21 equal to 0. Okay, so we've simplified everything, got rid of our radical. Notice that we are going to have a quadratic function, so it's going to be equal to 0. Now looking over here, what's one thing we should do to each term because we don't want a negative a value? Multiply everything by negative 1, and that's going to change the signs. So I have y squared minus 22y plus 21 equals 0. Now that we have this, this tells us we are going to factor using what method? The AC method. Okay, so doing the AC method, what is A times C? 21. What's our B value? Negative 22. What are two numbers that multiply to 21 but add to negative 22? Good, negative 21 and negative 1. So that means I'm going to rewrite my problem as y squared minus 21y minus y plus 21 equals 0. Now I have 4 terms, and that tells us we're going to factor by grouping. Okay. Once we factor by grouping, what is the GCF we can take out of the first parenthesis? A y, so we're left with y minus 21. What about the next parenthesis? Because we want them to match. Negative 1, so I'm left with y minus 21. So that means I have the factors y minus 21 and y minus 1 equals 0. From here, what do I need to do to figure out what my two values of y are? Both equal to 0. So y minus 21 equals 0 tells us that y is equal to 21. And y minus 1 equals 0 tell us that y is equal to 1. Okay. So before we can say that both of those are our answers, what's our last step? We have to check our work. So we're going to be plugging in 2 answers this time. We're plugging in a 21 And then we're plugging in a 1. And remember, we are plugging that into our original problem up here. Okay? So that's what I'm going to do next. So I'm just rewriting my problem so I have it over here so I can zoom back in. Okay. So first I'm going to plug in 21. So I have 21 plus 2, square roots of 4 times 21 minus 3 equals 3. All I did was plug in 21 in for y. And now I simplify. So 4 times 21 gives me 84. So this is 21 plus 2 square roots of 84 minus 3 equals 3. 84 minus 3 is what?
81.
81. And what's the square root of 81? 9. So I'm left with 21 plus 2 times 9 equals 3. 21 plus 18 equals 3, which gives me 39 equals 3. True or false? False. So that tells us that 21 is not an answer, extraneous. Now we have to plug in what number? 1. So I have 1 plus 2 square roots of 4 times 1 minus 3 equals 3. 4 times 1 is 4. 4 minus 3 is 1. And what's the square root of 1? 1. So 1 plus 2 times 1 equals 3. So 1 plus 2 equals 3. 3 equals 3. True or false? True. So that means our only answer is what? Y equals 1. Any questions on this problem? This was a long problem. Okay. Now let's look at the next concept where we have more than one radical. When we have more than one radical, we choose one radical at a time to get by itself. Okay? Notice how both of these radicals are already by itself, and what else is similar between them? They are both the third root. So if I was to raise both sides by the index, what is going to happen to these radicals? Good, they both cancel out at the same time. So this is, ultimately what we want. This does not always happen. Okay? So those cancel. Now we have no radicals and we just have what was under the radicals. So 2x minus 4 is equal to 1 minus 8x. And then here we're just solving this like a regular linear equation because we do not have any x squareds. We just have x's. So our job is to get all the x's on one side and all the numbers on the other side. So I'm going to move the 8x over, and I get 10x minus 4 equals 1. What should be my next step? Add 4. And I get 10x is equal to 5, which means x is equal to 1/2 because divide by 10. Okay. We still have to do what though? Check. So I'm going to plug in 1/2 into my problem. So I have the cube root of 2 times 1/2 minus 4 is equal to the cube root of 1 minus 8 times 1/2. I plugged in 1/2 in for my x's. Simplifying this, 2 times 1/2 is 1, and 1 minus 4 is -3. So I have the cube root of -3 equals, what's 8 times 1/2? 4. So what's 1 minus 4? -3. You don't even need to continue solving. Are these the same on both sides? So that means this is true or false? True. So that means our answer is 1/2. Okay. Okay, now let's look at 6. So notice on number 6, we have both of our radicals on the same side. Okay? We don't want that. We want one of our radicals to be by itself. So which would be easiest to get by itself, the first one or the second one?
Second one.
So I would say the first one, just because all I have to do is add that second one over.
That's my bad, because I was definitely thinking of adding that second one.
Because then we would have to deal with that negative and everything too. So I'm going to add the second one over to the other side. So I'm left with the square root of 3c plus 1 is equal to 2 plus the square root of c minus 1. Now that I have my 3c plus 1 square root by itself, I need to raise each side to the index. And what is that going to be? 2. So I'm going to square both sides. Notice I have to square that entire right side in parentheses. Okay, I can't just square the 2 and then square the radical. Whole thing has to be squared. When that happens, just my first radical cancels out. So I'm left with 3c plus 1 is equal to, what is that square telling us to do with that parenthesis? Write it twice. So that means we're going to use what method? Foil. Okay. So we're going to FOIL this out in order to simplify. So I have 3c plus 1 is equal to 2 times 2, which is 4. 2 times that radical, so plus 2 square roots of c minus 1. And then the bottom part, radical times 2, so plus 2 square roots of c minus 1. And then the radical times the radical. What happens when we multiply two radicals that are exactly the same together? What happens to the square root? Cancel. So I'm just left with c minus 1. Okay. Any like terms on the right side? Good. The 2 radicals. So we have 2 radical plus 2 radical, which is going to be 4. So 3c plus 1 is equal to, well, there's even more, because we could also combine the 4 and the negative 1. So we have negative 3 plus 4 square roots of c minus 1 plus c.
Wouldn't that be positive?
Yes, you're right. Positive 3, because 4 minus 1. Thank you. Okay. Okay. Now all we did is we got rid of one radical. We're going to have to do the whole process again to get rid of the other radical. So that means we need to get that square root of c minus 4 by itself. So what are we going to move over to the left side? The 3 and the c and the 4. So I'm going to subtract the 3 and subtract the c. And I get 2c minus 2 is equal to 4 square roots of c minus 1. Okay. Again, I want to get rid of that 4, so what I'm going to do to both sides? Divide by 4. Okay. So then I have 2c minus 2 divided by 4 is equal to the square root of c minus 1. Okay. From here, what am I going to do to both sides? Square it, because I got to get rid of that radical. So that means I have 2c minus 2 squared, okay, over 4 squared. I gave the square to each part of my fraction. And then the square root and the square cancel. So I'm left with c minus 1. Okay. What am I going to have to do to this top part? Write it twice in FOIL. So I have 2c minus 2 times 2c minus 2. Okay. Foiling that, I have 2c times 2c. What's that? 4c squared. 2c times negative 2. So negative 4c. Negative 2 times 2c. So we're doing the bottom now. Negative 4c. And negative 2 times negative 2 is positive 4. Okay. Any like terms we can combine? Good. So these negative 4c's. So we have 4c squared minus 8c plus 4. Okay. We still have everything divided by what, though? 16, because 4 squared is 16. Equal to c minus 1. Okay. We have a c squared in our problem, so that tells us what?
That we're going to have to put it in standard form eventually.
Good, that we need to have this problem equal to 0. Before we do that, we want to get rid of our fraction that has the 16 on the bottom. So what am I going to do to both sides? Multiply both sides. So everything by 16. That's going to cancel out the 16 on the denominators. So I have 4c squared minus 8c plus 4 is equal to 16 times c, so 16c, and 16 times negative 1, negative 16. We need this equal to 0, so what are we moving over to the left? Good, then minus 16c, and then add 16. Okay. So that means we have 4c squared, negative 8 and negative 16 is negative 24. C, 4 plus 16, positive 24, equals 0. Okay. We have a quadratic equation equal to 0, so we're going to factor using what method? The AC method. But before we factor using that AC method, do we see a GCF that we could take out to make our lives easier? Go to 4. So I'm left with c squared minus 6c plus 6 equals 0. I was just about to, that's supposed to be 20. 4 plus 16, 20. So this is supposed to be 5. Okay, thank you. So for using that AC method, our A times C is going to be what? Because we're only looking at what's inside the parentheses now. Only looking at this. 5. And our B is negative 6. So what are two numbers that multiply to 5 but add to negative 6? Good, negative 5, negative 1. So that means I have c squared minus 5c minus c plus 5 equals 0. Now I'm factoring using what method? Grouping. So what's the GCF I could take out of the first one? C, and I'm left with c minus 5. And what about the next one if I want them to match? Good, negative 1, c minus 5. So I have c minus 5 and c minus 1 equals 0. What do I do to get both of my answers? Good, c minus 5 equals 0 means c is equal to 5, and c minus 1 equals 0 means c is equal to 1. But remember we took out a GCF. What was that GCF? 4. So what are we going to have to do with our answers and that 4? We're going to have to multiply them. So each one by 4. So that means we have the answers of 20 and 4. And that was because we took out the GCF of 4.
In something like this, on the previous part where
Oops.
we had everything divided by 16, if we had reduced those fractions at that point, instead of multiplying by 16, if we had reduced them to like 1 over 4 or 1/2,
Okay, I see what you're saying.
you know, like could we have done something that way so we're not having to deal with the GCF later on?
Yes, because if you did that and you reduced all the fractions, then instead of multiplying everything by 16, you're probably multiplying everything by 4, whatever would be the new denominator. And that could potentially get rid of that GCF.
Okay,
But your numbers would be a little off, so you would still get 20 and 4 as your answer.
gotcha. Okay.
Okay. Last step to see if our answers are correct. What do? We check. So I'm going to rewrite the equation down here. Okay, we're first going to check 20, then 4. Okay, so the square root of 3 times 20 minus 1 minus the square root of 20 minus 1 is equal to 2. 3 times 20 is 60. 60 minus 1 is 59. 20 minus 1 is 19. These right away tell me that they're not perfect squares, correct? So that means we are going to get decimal answers. So in our calculator, I am going to do the square root of 59. Okay, and then the square root of, so this is like 7.68. And then the square root of 19. $4.35. If we subtract those, are we going to get 2?
No.
No, so this is false. So this one's not. Okay, then let's check if we plug in 4. So the square root of 3 times 4 minus 1 minus the square root of 4 minus 1 equals 2. In the first square root, we have 12 minus 1, so 11. And then the square root of 3 equals 2. So I'm going to do the same thing. Do the square root of 11, which is 3.32. The square root of 3, which is 1.73. Is that going to give us 2? No, it's going to give us a decimal around 2. So again, this is false. So that means the answer to this problem is what? No solution.
Is that only number 6 right there? All of that?
Yeah, it's all 6. Okay, let me see how much. Okay. We have one more of these problems, and then we're going to do a couple word problems. Any questions so far? There won't be more than one of these on the test. Just one. Because it's a lot. Okay, so that was number 6. Let's look at the last one for this example, number 7. Okay. For number 7, our first thing to see is if we have a radical by itself. Do we have one by itself?
Yes.
Yes, so what are we going to do to both sides? Square both sides. So that means we have 5x plus 4, because they cancel out, is equal to, what is the right side telling us to do? Write it twice. Write it twice and use what method? FOIL. Okay, so we're going to FOIL this. Okay, so when we FOIL this, we have 1 times 1, which is 1. 1 times the radical, which is just that radical. Radical times 1, so again the radical, that 5x minus 3. And when we do a radical times a radical, what happens to the square roots? Cancel. So the square root of 5x minus 3 times the square root of 5x minus 3 is just going to be 5x minus 3. And then I'm going to bring down that 5x plus 4. Okay. Any like terms on my right side? Good, so these radicals and then the numbers. So I have 5x plus 4 is equal to negative 2, because 1 minus 3 is negative 2, plus 2 square roots of 5x minus 3 plus 5x. So I just combined all my like terms. So getting to this step, we got rid of one radical. Is there still another? Yes, so what do we need to do with that radical? We need to get it all by itself. So we're going to add the 2 over, subtract the 5x over. When we do that, what happens to the x's on the left side? Cancel, so I'm left with 6 is equal to 2 times the square root of 5x minus 3. Now I need to get rid of that 2, and I'm going to do that how? Divide both sides by 2. So I get 3 is equal to the square root of 5x minus 3. Notice because that x went away, that 5x, we're not going to have to do any factoring here. This is just going to be a linear equation. So in order to get rid of that radical, what am I going to do to both sides? Square it, because I want it to cancel. So I have 3 squared, which is 9, is equal to 5x minus 3, because the radical and the exponent cancel. Okay. Now I just need to get x by itself. So what's my next step? Add 3. So I get 12 is equal to 5x. And what's my last step? Divide by 5. So I have x is equal to 12/5. Okay. I still need to plug in that 12/5 into my original problem to see if it is a true statement. So I'm rewriting my problem that 5x plus 4 is equal to 1 plus the square root of 5x minus 3. I'm going to plug in that 12/5. So I have the square root of 5 times 12/5 plus 4 is equal to 1 plus the square root of 5 times 12/5 minus 3. What's going to happen to that 5 and the denominator 5 on both of them? They're going to cancel. So I'm left with the square root of 12 plus 4 is equal to 1 plus the square root of 12 minus 3. 12 plus 4 is 16. And what's the square root of 16? 4 equals 12 minus 3 is 9, and the square root of 9 is, so 1 plus 3. So I have 4 equals 4, which is true or false? True, so that means my answer is 12/5. This is part of it. Okay. Any questions on this concept of getting the radicals by itself and answering the problem? Okay. So So then we have our last concept here, and that is application of radical equations and functions. And I believe just 2. Yep. Okay. Okay, so the question states, if the distance around the bottom of a pyramid is 921.6 meters and the height is 146.6 meters, what is the volume of the pyramid if the base is square? So it says use the following formula where B is the base, H is the height, and V is the volume, where we have B is equal to the square root of 3V over H. Okay. So before we do anything here, we need to find because what is it asking for? The volume. The volume of the pyramid if the base is square. So in order to find the volume, it's easiest if we could get V by itself before we plug in any of our numbers. Okay? So this is going back to those literal equations where we had to rearrange the equations that had multiple variables. Okay, so we're going to get this equation where V is by itself. So we have B is equal to the square root of 3V over H. What would be our first step to get the V by itself? We got to get rid of that radical. So what can we do to both sides? Square it. Okay, which means the radical is now gone. And we have B squared is equal to 3V over H. Again, we want the V by itself. So what do we need to get rid of? The H. So what are we going to do to both sides to get rid of the H? Multiply. So I'm going to multiply both sides by H, which means the H's cancel on the right side. And I'm left with HB squared is equal to 3V. What's my last step to get V by itself? Divide by 3. So I have V is equal to HB squared divided by 3. That is my new equation. Now we're just going to plug in the numbers they gave us, and we're going to get our answer. So what number did they give us for height?
146.6.
Good. And what about the base, B? Right here, yep, the bottom, 921.6. So I'm going to plug those numbers in. So I have V is equal to the height, so 146.6 times the base, so 921.6 squared.
Really quick.
Yes.
I apologize for interrupting, but it says the distance around the bottom of the pyramid, so wouldn't that be the perimeter of the whole square? So wouldn't we have to divide 921 by 4?
Perfect, yes, yes. That is correct. And that's fine. I don't mind if I get interrupted. So okay, so that's a great point, and that's something that I did miss here, because it says the distance around the bottom is that 921.6. So distance means it's the perimeter around this entire square. So that means we need to find just one side, and this gives us the total for all 4 sides. So we would have to take that 921.6 and divide it by 4. When we do that, we get 230.4. This is our B value. So going back into our problem, we have V is equal to H, which is 146.6, times B squared, so 230.4 squared, all divided by 3. So if you type that into your calculator, you should get volume is equal to 2594046. So this is 2,594,046. What would be the units for this?
Meters squared.
Meters cubed. Because when we're talking about volume, it's always cubed. If we're talking about area, it's squared. So this is our answer. Okay. Any questions? Okay. Last problem here. It says use the following equation and graph to answer the questions below. So it gives us the equation and the graph. It says find the speed of a car before the brakes were applied if its skid marks are 361 feet long. So here, our x value is the length of the skid marks. So if we look at our problem, our equation, we have s of x is equal to 3.8 square root of x. Since this is an x value, what could we do with that number?
Plug it into the equation.
Good, we just plug it in. So s of 361 is equal to 3.8 times the square root of 361. Typing that into your calculator, we see that the square root of 361 is 19. So we get the answer of 72.2 miles per hour. It's miles per hour because the y value, that y-axis, is speed. Okay, and we could double check on our graph too. We could say, okay, 361 is about right here. Follow it all the way up. Notice how we are between 60 and 80, which makes sense because we got 72.2. How long would you expect the skid marks to be if the car had been traveling the speed of 50 miles per hour? Where would we plug in the 50? For x or y? Y. So we would do 50 is equal to 3.8 square roots of x. What would we do to get x by itself? Divide by 3.8. And we get 13.158 is equal to the square root of x. And then our last step here would be what? Square both sides. So we'd get x is equal to 173, what? What's our units? Good, feet. Meaning if a car was going 50 miles an hour and they had to brake, their car would still travel 173 feet before it came to a full stop.